Welcome to this video on forces and elasticity. This revision guide covers everything you need for GCSE Physics, including how forces change object shapes, Hooke's law, and key exam terminology. In this video, we will explore 4 key topics: how forces change shape, the difference between elastic and plastic deformation, Hooke's law, and essential exam tips to help you succeed. Chapter 1. How forces change the shape of objects. When a force acts on an object, it can cause it to change shape. Depending on the direction and type of force, an object might stretch, compress, bend, or twist. Stretching increases an object's length by pulling it apart from opposite ends. Conversely, compression decreases length by pushing forces towards the object, effectively squashing it. It is important to remember that both stretching and compression require a pair of opposing forces. A single force would simply cause the object to accelerate. Physicists classify deformation into 2 types: elastic and plastic. The fundamental difference lies in whether the object returns to its original shape after the force is removed. Elastic deformation is temporary. When the applied force is removed, the object's atoms return to their original positions, and the object regains its original shape and size. Plastic deformation is permanent. The force applied is strong enough to break and reform atomic bonds in new positions, meaning the object stays deformed even after the force is removed. Here is a quick comparison. Elastic changes are temporary and return to the original shape, whereas plastic changes are permanent and leave the object deformed because they exceed the elastic limit. The elastic limit is the maximum force an object can withstand before it undergoes permanent plastic deformation. It is a critical threshold for understanding how materials behave. Understanding the elastic limit is vital. Below this limit, deformation is elastic. At the limit, you reach a boundary point. Beyond it, the deformation becomes plastic, potentially leading to fracture. Chapter 2 focuses on extension, which is the increase in an object's length caused by a stretching force. Remember, extension is calculated by subtracting the original length from the new length. For a worked example, if a spring's natural length is 0.10 meters and it stretches to 0.16 meters, the extension is 0.06 meters. Always remember to subtract the natural length, not 0. Chapter 3 covers springs and Hooke's law. This law describes the relationship between the force applied to a spring and the resulting extension. Hooke's law states that extension is directly proportional to the applied force, provided the elastic limit isn't exceeded. This means if you double the force, the extension also doubles. Hooke's law is defined by the equation F equals K times E. F represents the force in newtons, K is the spring constant measured in newtons per meter, and E is the extension in meters. It is essential to recall these units instantly for your exam. Force is in newtons, extension in meters, and the spring constant in newtons per meter. Getting these right is an easy way to earn marks. The spring constant, K, measures stiffness. A high K value means a stiff spring, requiring more force to stretch. A low K value indicates a soft, easily stretched spring. You can also rearrange the formula to find K or the extension. Let's look at a worked example. With a spring constant of 40 newtons per meter and an applied force of 8 newtons, we rearrange the formula to calculate extension. 8 divided by 40 equals 0.2 meters, or 20 centimeters. In this second example, a force of 15 newtons causes an extension of 0.05 meters. Calculating the spring constant K gives us 300 newtons per meter, indicating a fairly stiff spring. Chapter 4 covers the force extension graph. Understanding these graphs is critical for interpreting material behavior, stiffness, and identifying when a material moves from elastic to plastic deformation. These graphs show 4 key features: the initial straight line proportional region, the limit of proportionality, the elastic limit where permanent change begins, and the final curve section indicating plastic deformation. A straight line through the origin confirms direct proportionality, meaning Hooke's law is obeyed. In this region, the line's gradient equals the spring constant K. A steeper gradient represents a stiffer spring. Remember, the steeper the gradient on a force extension graph, the stiffer the spring. You can calculate the exact spring constant by dividing the change in force by the change in extension for any 2 points on the linear section. To calculate the gradient, pick 2 points on the straight line part of your graph, find the rise in force, and the run in extension. Divide the rise by the run to find your spring constant K. Once you pass the limit of proportionality, the graph starts to curve. Hooke's law is no longer applicable here, because the relationship is no longer linear, though the spring might still return to its original shape. Don't confuse the limit of proportionality with the elastic limit. The limit of proportionality is where linearity ends. The elastic limit is where deformation becomes permanently plastic. To summarize, the 3 regions are: the linear Hooke's law region, the nonlinear elastic region, and the final plastic region where the object remains permanently stretched. Chapter 5 looks at investigating Hooke's law experimentally. Understanding the methodology is as important as the physics theory for your exams. The process involves hanging a spring, measuring its natural length, adding known masses to measure the new length, calculating the extension, and finally plotting the results on a force extension graph. When conducting your experiment, pay close attention to your variables. Your independent variable is the force applied, measured by adding masses. The dependent variable is the extension, and you must keep the spring and ruler position constant as your control variables. To ensure accurate results, watch out for common errors. Parallax error occurs when reading the ruler at an angle, so always read at eye level. Avoid spring oscillation by waiting for it to stop moving, and never overstretch the spring, which causes plastic deformation. Here are the essential equations for your GCSE exam. Remember Hooke's law, F equals K times E. You should also be able to rearrange this to solve for the spring constant, K, or the extension, E. And recall that extension is new length minus original length. In the exam, use precise terminology. Extension is the increase in length. Elastic deformation is temporary, returning to the original shape. Plastic deformation is permanent, where the object remains changed. The elastic limit is the maximum force before plastic deformation, and the spring constant measures stiffness. Avoid common exam pitfalls. Never confuse elastic and plastic. Always check your units, converting centimeters to meters, and remember that Hooke's law only applies within the linear region of your graph. Once the graph curves, Hooke's law no longer holds. Use these simple memory aids. Think plastic equals permanent for permanent deformation, and elastic equals escapes back to its original shape. These associations will help you stay accurate during high-pressure exams. Let's practice some exam questions. If a spring with a constant of 250 newtons per meter has 5 newtons applied, the extension is 0.02 meters. A rubber band returning to its original shape is showing elastic deformation. A steeper gradient on a graph indicates a stiffer spring. For our final practice, a spring stretching from 12 to 19 centimeters results in a 0.07 meter extension. A force of 20 newtons causing 0.08 meters of extension gives a spring constant of 250 newtons per meter. A permanently bent wire signifies plastic deformation. Use the full topic summary as your final revision checklist. Ensure you can confidently define all terms, apply the equations, and interpret the force extension graphs before you head into the exam hall. You are now ready for your exam. Remember the golden rules. Elastic is temporary, plastic is permanent, and Hooke's law requires the correct units. Good luck with your studies and your upcoming test.